Alright, let's do some Monopoly. So first of all, let's look at the demand curve that is facing the firm. Remember, we just saw in perfect competition that the firm faces that perfectly elastic demand for its output, even though the market demand curve and all the individual demand curves for that product were downward sloping, because the firms were such a small part of the market that the market can absorb all of their output at that market price, and you can sell another unit of output without having to drop the price. That also meant that there was only a quantity effect when it sold one more unit, because it would just get the extra price. That's why marginal revenue was equal to price. Extra price for that one unit of quantity. Each little rectangle that you'd be adding there would just add to your revenue, and that gave us that straight line total revenue curve. So there was no price effect because we weren't losing revenue from having to drop the price. Now Monopoly, as most people know, Monopoly is just going to be a single seller. So as opposed to one of a large number of firms, we now have one firm. It's the only seller. And so instead of being a price taker, a Monopoly is going to set the price. And remember, there is a market and a market demand curve for this product, whatever the product that the Monopoly is selling here. And now, since the Monopoly is the only seller, it is just facing the entire market demand curve. So in other words, it is facing a downward sloping demand curve as opposed to a perfectly elastic demand curve. So if you're not comfortable with the relationship between demand, revenue, elasticity, you should go back to my video on demand elasticity, where we went over this in a little bit of detail. But now we need this when we start talking about Monopoly. So as we saw, we're going to have this elastic range in the top of our demand curve. We're going to drop the price, sell another unit of quantity, and then in this range, remember, elasticity is going to be the percent change in quantity over the percent change in price. In this elastic range, that quantity effect, the extra revenue you're going to get from selling another unit of quantity, is going to outweigh that price effect. I am going to lose $1 on that first unit that here I was selling for 9. I'm going to have to drop the price to 8, so I did lose due to the price effect. But since the quantity effect outweighs the price effect in this elastic range, this is total revenue down here versus quantity. You can't really see, but quantity is going up in that elastic range as you raise your price, or as you lower your price. If you raise your price, you're just going the other way. Your revenue is going to fall. Until we get to that unit elastic point, that's where elasticity is going to change. So revenue is continuing to go up as we move along this curve until that point. Then that gives us our unit elastic point. And if we keep going, we're now in the inelastic range, where lower price, more quantity, price effect outweighs the quantity effect, and total revenue is falling. So the Monopoly now has to deal with this relationship as it decides where it wants to set its price, because it's choosing where it wants to be on this demand curve, because it can just set whatever price it wants. And a demand curve is going to tell you how much output you can sell at that particular price. So the only thing we have to add here that we didn't have before is marginal revenue. So remember, marginal revenue is just the change in total revenue for a given change in quantity. And it's just a straightforward extension of what we just did, because so what's going on is, if I lower my price to sell that next unit, since we're assuming we're a single price monopoly, I'm gonna sell all my units at one price. We're going to change that assumption later, but I'm just going to pick one price to sell all my units. Well, if I want to sell that next unit, I have to drop the price not just on the next unit, but on all my units, so including the first one, which is why we have that price effect and quantity effect. So the extra revenue that I get, the marginal revenue, is not just the price. I'm selling that next unit at $8, but I also lost revenue due to that price effect, so the marginal revenue is actually below the price. Right, I'm going to get $8 on the last unit, but when I account for the lost revenue due to dropping the price on all my earlier units, it puts the marginal revenue below the price. So I'm setting the price based on the demand curve, setting that price of 8 and selling 2 units, but the marginal revenue, except for the very first fractional unit up here, or if we just use discrete units, the first unit, right after that first unit, then I have to drop the price on any earlier units that I was selling. So if I keep going, that price effect is getting bigger, right? So as I move along this curve, remember in the inelastic range, my price effect is now bigger than the quantity effect. So because now as I move along here, there's more and more output that I have to drop the price on, which is why there's a bigger effect in terms of the difference between price and marginal revenue. But as long as I'm in the elastic range, marginal revenue is still positive, right? Because remember, total revenue is going up. Marginal revenue is the addition to revenue as we increase output. And so this is positive, but see, it's positive. It's rising at a decreasing rate, which is why this is falling. Right? It's falling, but still positive because that's the slope of this curve. Right? The slope is getting smaller. The rate of change in total revenue as I increase output is getting smaller and smaller, and up here it's zero. Right? So finally, when I get to here, that extra unit that I'm selling, I have to drop the price on all the earlier units that I'm selling, and once I account for that, I'm not actually adding any revenue. I'm right at that unit elastic point, and so total revenue stopped rising, so that's my maximum revenue point, which is why this crosses right at that halfway point, because we saw that midpoint of this demand curve is that maximum revenue point, the unit elastic point. So that's why when you draw this marginal revenue curve, it's going to hit right at that midpoint, halfway to the end of your demand curve here. Now marginal revenue is negative, right? Which means total is falling, right? So again, we have to be comfortable with the relationship between totals and marginals, right? When total is falling, but still positive, marginal is negative, right? So here, total revenue is still positive, but it's falling as I keep going, and so the addition to revenue is negative, right? I add one more unit, I have to drop the price in all my units, so the extra revenue is I'm actually losing revenue. The marginal revenue is negative if I move along that unit elastic point. So we're not going to worry too much about trying to get marginal revenue numbers from a graph. You have to be a little bit careful here because that first unit, so let's say I go from 0 to 1 and sell that first unit. Well, I had 0 revenue at 0 and I have 9 at 1, so I'd actually have to go to that halfway point. Right at 0.5 is marginal revenue of 9. Don't really worry about that too much. You're not probably going to have to read off numbers from a graph. If you needed marginal revenue numbers, you'd actually use discrete units here. So here we have these smooth curves where really can adjust units on a fractional basis if we wanted to, although we're normally using whole numbers. So if we're just given the numbers, then it's pretty straightforward. I'm just gonna, what's my price, what's my quantity, what's my total revenue, and so if I went from 0 to 9, then I added $9. Right, the next one I went from 9 to 16, so the extra revenue is 7. So notice as soon as I go past that first unit, the marginal revenue is always less than the price. Right, the next unit I'm selling for 8, but I only added $7 to my revenue because I lost revenue due to that price effect, and that effect is going to get bigger and bigger. Right, next unit I sell for 7, but I only added $5 to my revenue. Next I sell for 6, I only added $3. Right, there's that unit elastic point in there in the midpoint, but all the way on the other end of the demand curve, I'm now in the inelastic range. Right, so if I go from 2 to 1, my revenue falls. Actually lost revenue. Marginal revenue is negative. I can keep going here in terms of my marginal revenue curve. Marginal revenue is negative in that range. So you have to be really comfortable with this relationship between marginals, totals, elasticity, revenue. You have to have a really good grasp of that. But generally, we're just using these abstract curves where I'm not trying to measure it exactly what these numbers are, but we just want to understand the relationships between these curves. But you might get some kind of calculation where you need numbers, but then it'll be pretty straightforward, something like this. Okay, so if we're going to draw a monopoly, we're going to start with our demand curve or marginal revenue curve. So remember, draw this right at that halfway point so that your graph is not distorted, because that's marking off your midpoint where your unit elastic point. So kind of think of the total revenue curve underneath there where it's going to be maximum at that point. And so you want that right at that midpoint, right? If your demand curve hits the X, so you could have a flatter demand curve that you can't really see where it hits, but you'd have to sort of estimate what your marginal revenue curve should look like. But if it hits the axis here, just go halfway so that you have the elastic range properly on your demand curve, and then you have the inelastic range.